This lesson is for solving systems using substitution. The goal of substitution is the same as graphing. We're still solving a system. We're still looking for the intersection point. Substitution is an algebraic method of solving systems, commonly used when a variable is isolated or can easily be isolated. For example, something that's already isolated might be something like y equals 2x minus 3, because the variable here is already isolated. Or it could also be something such as 2x minus y equals 5, because we should be able to relatively easily isolate for y. That would be your rearrangement for y. I'm going to take you through a couple of examples. So here we have an example where we're all asked to solve the system using substitution, and we're given a system of equations. I always start out problems like this by labeling my equations, because I'm going to refer to them during my solution, and I want someone else to be able to follow my thought process. This is a habit that you should get into right away. So I can see when I look at equation 1 here that the y is already isolated. So I don't have to do any work in terms of isolation. I just have to notice the substitution. So we have a y here and a y here. So I'm able to easily substitute in this piece right in for y, since they're equivalent. So I'm going to put here sub 1 into 2. Nice and easy for everyone to see what I'm doing. 2x plus x plus 4 equals negative 1. And now it's just a matter of simplifying and solving. So I've got some like terms. I've got a 2x and an x. So 3x plus 4 equals negative 1. And then I need to isolate my x, so I'm going to start by subtracting 4 from both sides. So that gives me 3x equals negative 5. And now I'm going to finish isolating x by dividing by 3 on both sides. So x is negative 5 over 3. And we're going to leave that as a fraction, because we want the exact number for our answer. And now I just need the y value that goes with it, right? Because we're looking for the solution to the system, so we need an x and a y value. So now I'm going to sub x into 1. We always sub these things back into the opposite equation. It can help us catch our own errors sometimes. So, and especially in this case, we already have isolated y equals, so it makes life a little easier. So y equals negative 5/3 plus 4. Because remember, equation 1 comes from here. So we have negative 5/3 plus 12/3. So y is 7/3. Therefore, the solution is negative 5/3 and 7/3. And you can also kind of see why we may not have graphed this one. It gave us fractions on a graph. It's a lot harder to see fractions and that exact answer. So the algebraic method made sense, and substitution worked nicely. We'll do one more example here. We've got two new equations. We're going to solve the system using substitution. Again, I'm going to label equation 1 and 2. And I want you to notice this time that neither one of these has an isolated variable, right? X and Y are both on one side, X and Y are both on one side. But you should also notice that we could solve this system in a couple of ways, because we could take equation 1 and isolate for Y, or we could take equation 2 and isolate X. It doesn't actually matter which way you do it. I know you're more used to seeing Y equals mx plus b for lines, but we can write it either way in terms of solving for substitution. So I'm going to write this out as I would if I was doing a full solution. Again, this is a habit you should get into. So from equation 2, we have x equals 6 minus 2y by subtracting 2y from both sides. And for simplicity's sake, I'm going to call that equation 3. So I'm going to substitute 3 into 1, right? It came from 2. If you substitute 3 into 2, you will end up getting 0 equals 0. You can try that if you want. Sub 3 into 2 instead, and you'll just get something that simplifies to 0 equals 0, which will not be helpful. So make sure you substitute into the opposite one. So we have 3 times 6 minus 2y minus y equals 4. And again, I want to simplify and then rearrange and solve for y. So we get 18. 3 times 6 is 18. Minus 3 times 2 is 6y. Minus y equals 4. So we have 18 minus 7y equals 4. Sorry, my equal sign is kind of creeping to the left there. So let's subtract 18 from both sides. So we got negative 14. This looks like it's going to work out nicely and give us a nice whole number. And divide by negative 7. Negative 14 divided by negative 7 is positive 2. So there I have my y value. Sometimes I might do that just so it's easy to come back to later. And I'm going to continue my solution up here. So now we're going to sub into equation 3, right? That's the one where I have x isolated. So it'll give me that nice answer. X equals 6 minus 2 times 2. Simplify 6 minus 4 equals 2. So therefore, the solution is 2, 2. And we can also check our work. So we can check. And you should do this with both equations. So let's take equation 1. And our left side should equal the right side. Both x and y are 2. 3 times 2 minus 2 equals 6 minus 2 equals 4. So that checks. That's what we wanted. And equation 2, 2 plus 2 times 2, 2 plus 4 equals 6, and that's what we wanted. So there is our check of our work. And in this case, we got whole numbers, so you could also graph this to check your answer.